Okay, here's a particular applied use of a vector equation of a line to find a particular point B that lies on this line and is 44 units from this point. So, because we know B is on this line, we can write B as a vector, or B's position as a position vector. And that is going to be 6 lambda take 11, 15 take 6 lambda, and 7 lambda plus 3. So that's just expanding this out into 3 components, as it were. Right, now the vector A to B, as we've done from our GCSE geometry, is back along A and forward to B. It's the difference between them. So we're going to do 6 lambda take 11 take 1, 15 take 6 lambda take 3, and 7 lambda plus 3 take 17. And that gets us this, 6 lambda take 12, it gets us 12 take 6 lambda, and it gets us 7 lambda take 14. So that's the vector AB. We've done that using the coordinates of B from the line and the difference between that vector and that vector. So we know the size of this vector is 44. The size of a vector is just Pythagoras, although it's going to end up being horrible. So 6 lambda take 12 squared plus 12 take 6 lambda squared plus 7 lambda take 14 squared is 44 squared, because that's the distance we're given. A whole bunch of just symbol crunching now. We've kind of done all the hard vector stuff. Knowing to write B as a single vector is an important step. Knowing to find the vector form of A to B is an important step. Knowing that the distance is easy to work out with Pythagoras is an important step, and from there it's just can you move symbols successfully and accurately, which is not always straightforward, but we get good start. That's not 36 lambda squared take 144 lambda plus 144 from that first bracket, plus 144 take 144 lambda plus 36 lambda squared from the second bracket. The third bracket we get 49 lambda squareds, 196 negative lambdas, and 196, and that equals 44 squared, which I worked out earlier as 1936. So it's a whole long horrible butt of algebra, but it works out eventually. 36, 36, 49 is 121 lambda squareds. 144, 144, 196 is negative 484 lambdas. 144, 144, 196, and bringing this over is negative 151452. So now we've got a quadratic equal to 0. You've probably got an automatic solver on your calculator, but this does in fact simplify. These all are multiples of 121. So it's lambda squared take 4 lambda take 12 is 0, and this factorises neatly. Lambda lambda take 6 plus 2, which means that lambda is 6 or negative 2. So if we take lambda to be 6, we get B is 6 lots of 6 take 11, 15 take 6 lots of 6, and 7 lots of 6 plus 3, which is 36 take 11, 25, negative 21, 45. Or, if we take lambda to be negative 2, we get B as 6 lots of negative 2 take 11, 15 take 6 lots of negative 2, and 7 lots of negative 2 plus 3. Negative 12 take 11 is negative 23. 15 plus 12 is 27, and negative 14 plus 3 is negative 11. So those 2 points, those 2 coordinates, those 2 vector form of the coordinates, are the locations B could be such that it sits on that line and is that far from that point. Like, not ridiculous, but time consuming. Enjoy, I suppose.